Hello team, welcome back. Welcome to Terraform training. And in this section, we will learn about the Terraform variables. Variables are very important in Terraform because Terraform completely depends on the configuration file. And if we are going to create the static configuration file, then that will be project dependent. So we need to make sure that we will create the flexible configuration file so that whenever we will use the configuration file, these file could be the project agnostic. So let's learn about the variables in the Terraform. So variables are very necessary to parameterize our deployments using the Terraform. Whenever we want to parameterize the deployment that we can supply the runtime values to the deployment configuration, we need to use the variables. Input variable enable user to pass the configuration value at the time of the deployment. That is the main purpose of the variables inside the Terraform, because for the deployment automation we are writing the configuration file in the Terraform, and we need to make sure that most of the values which we are using inside the configuration file, they should be configurable, or user can pass these values from the outside of the configuration file. Using Terraform input variable is one way of deploying deployment, staging production environment using the same Terraform resource declaration with slightly different configuration. And that is the thing we are talking about, that the same configuration can be used across the environment if we have the flexible configuration file, so that we can pass the environment specific configuration at the runtime to the configuration files, and configuration file will act accordingly without change in the configuration file itself. So let's see how we can define the input variables in the Terraform. Terraform input variable are defined using a variable block that defines the variable name and other options parameter for the variable. So we have two ways to define the variables inside the Terraform. Either we can define the variable in a simple format, we can define the variable, then variable name and the variable value. Or the second way is, which is correct, define the variable block. Inside the block, we will define the variable name and the variable value. Plus, if we have some other options like the default value of the variable, the description of the variable, the type of the variable, then we can define the supportive parameters as well. These variable blocks can be placed inside the .tf file within your Terraform project, with a common location used within the file named variable.tf. So if you want to define all the variable in a single file, you can create a single file called variables.tf, and Terraform will read all the variables from that particular file. Now let's discuss about the definition of the input variable. So the variable block is defined with the variable keyword followed by the name of the input variable. Also, the required type properties must be added to define the data type of the variable, such as a string, number, object, and other supported data. So as I told you, inside the block, you can define the variable name, variable value, variable type, and the declaration of the type. You can define the default value of the variable. Also, you can define the description of the variable. If there is some other property which needs to be associated with the variable, you can define these properties as well. So here is the sample how we can define the variable inside the Terraform. And the first one, we are defining the variable name is the environment, and type could be the string. In the second one, we are defining the supporting parameter as well. We are defining the variable location, the type is a string, then we are defining the default value of the location, and then we are defining the description of the location. So there is no limitation inside the block. If you want to define the single type, you can define the single type. If you want to define the associated or metadata regarding the variable, you can define the metadata regarding the variable as well. Within the input variable, we can also provide the condition. It means we can also provide the conditional input variable. Please make sure if you are going to use the conditional input variable, then the conditional variable is only applicable with the HashiCorp Terraform version 0.13.0. If you are using the Terraform version lower than 0.13.0, then you cannot use the conditional variable inside your Terraform. So when defining the input variable for a Terraform project, the input variable can have a custom validation rule defined, right? And the custom validation rule for the input variable are defined by the adding a validation block. Inside the validation block, you can put the condition and you can put the regex. Going further in this course, I will show you how we can define the conditional variable inside the Terraform. And here we are sharing an example of the conditional variable. So suppose we are defining the variable called location, right? Then we are defining the type, which is a string, and inside the description we are defining the description of the variable. Within the variable block, we are defining the another block which is called validation, right? Validation is the another block within the variable block where we are defining the condition for this particular location block. and condition equals to contains, and inside the contains we are defining few location, right? The first is estus and second is vestus, and then we are converting the location inside the lower case. If the given location is not estus and vestus, we are defining the error message as well. Unsupported as your reason is specified, supported reasons include estus and vestus. So this is the one way how we can define the conditions. We can have multiple conditions available in the Terraform. Going forward, we will learn about the other conditions as well. Then we have the multiple types of the variable inside the Terraform. First, we have the primitive types, and Terraform supports the three primitive time input variable like string, number, and boolean. If you have some knowledge or experience in any programming language, you are much aware with the string, number, and boolean type of variables. A string will contain the string kind of data, number will contain the numeric data, and boolean will contain the data like true and false only. The second one is the complex type variables, and complex type allow you to group multiple values together into a single variable. So whenever we want a collection of the values in a single variable, we will use the complex type of the variables. Like that is something array, array list, linked list, hash map inside the Java, and list, tuple, and set inside the Python, right? So if we want to collect a multiple values in a single variable, we need to go to the complex type. Complex type is also defined in two type. First is the collection type and second is the structural type. Collection type is a collection of multiple values grouped together as a single value. Inside the collection type, you can group the similar kind of values, right? So we have the list, a sequence of the values identify the index starting with 0. Then we have the map. Map is a collection value which will define the value inside the key value pair. Then we have the set. Set is a collection value, unique value without a secondary identifier or the ordering. This is similar with the Python list, map, and set, right? If we will go with the structured one, then structured has the then a collection of the multiple values of several distinct type grouped together in a single value. It means the value which we are grouping together in a single variable, but the type of these values are different. Then we need to use the structure type. Structure type is something like the object. We are creating the object of the multiple values. So the first one is the object itself, which is a collection of the values, each with their own type, and second one is the tuple, right? The sequence of the values each with their own type. It means we can group string, number, boolean together. We can group the list, map, and set together. We can group the string, number, list, set together. So there could be the n number of combination which you can group together within the object and the tuple, and you can use them. So this is the introduction part of the variables. We have learned about the use of the variables. We have seen some example of the variables, the declaration of the variable, and we have learned about the type of the variable. In the coming lecture, we will see how we can use the variables in the configuration file to make the configuration file more flexible and environment agnostic. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And today we will see how we can use the variable inside the configuration file. So we have discussed about the variables, the type of the variables, the declaration of the variable. Now we will see how we can use the variable to make the configuration file more flexible. So as I'm repeating it from starting, that single place configuration is not a good idea, right? We need to refactor the configuration file, and inside the multiple configuration file, we need to use the variables. Use variables to manage the secret. We can use the variables to manage the secret, manage the sensitive data. When we are going to use the secrets as a variable, then we don't need to push the AWS credential inside the Git repo. If we are pushing the AWS credential inside the Git repo, then that is not a good idea, because Git repo sometimes is public or publicly accessible within the organization. So in your organization, who can clone that Git repo, they may get the credential of your admin user in the AWS account, and that is not recommended from the security point of view. Second is user variable for the dynamic element like AMI. We can use the variables for the dynamic elements like the AMI definition, right? And some other dynamic values if you have something inside your configuration file. Variables makes the file more flexible and environment independent. Whenever we are using the variable inside the configuration files, so we are making the configuration file more flexible and environment independent, because for each environment we can create the variable set and we can use the environment wise variable set for the configuration files. So in the last section, we have used a create instance.tf file, which looks like this. First, we was providing the provider. Inside the provider, we was providing the access key, secret key, and reason. Then we was providing the resource AWS instance, right? And we was providing the AMI instance type and the instance name. This is the create instance file which we was using in the earlier lecture. Now suppose we want to defactor this particular creation file. Now suppose we want to defactor this particular create instance file. We have already seen that we have created another file called provider.tf, and inside the provider.tf we have provided the access key, secret key, and the reason. But over here again we are basically hard coding the values. So suppose now I want to pass the access key, secret key, and reason with the help of the variable. So how can I achieve it? In that case, the format will be look like this. We will have the provider, then inside the access key, we will use var.aws underscore access underscore key. Here aws underscore access underscore key is the variable name, right? Similarly for the secret, we have the var.aws underscore secret underscore key, and for the reason aws underscore reason. We need to use the var to read the value of the var inside the Terraform, right? And the syntax will be like dollar, then we need to define the curly braces, and inside the curly braces we need to define the var, then the name of your variable. This is global syntax inside the Terraform, so every time whenever we are using the variable we need to use these kind of syntax. After this, we will create the vars.tf, or you can create the variables.tf file. Inside the vars.tf or the variable.tf file, you can declare your variable. So over here, we are declaring the variable AWS access key. This variable is a null. Then we are defining the another variable AWS secret key. This is another a null variable. Then we are defining a variable called AWS underscore reason. Same three variables we are using inside the provider.tf file. But inside the AWS underscore reason, you can see I'm defining a property called default. It means if user is not providing the AWS.reason, then you can use the default US East 2, right? But if user is providing the AWS reason, then you need to use that particular reason. So this is the variable.tf file or vars.tf file which you can create. So we have created the two files, the provider.tf and the vars.tf. Inside the provider.tf, we are going to use the variables, and inside the vars.tf, we will declare the variables. Now third file, we will create the terraform.tf vars. Terraform.tf is a file in which file you can keep your secrets, right? Over here I'm defining the secrets blank, but you can keep your secrets inside this particular file. You can keep your AWS access key, secret key, and the reason, right? If you're not providing the reason, then the default value of the reason US East 2 will be picked at a runtime. Now to avoid to push that particular file in the GitHub repository, you can include that particular file inside the git ignore, so that whenever you will commit your code, this file or this particular file will not be committed inside your code repository. And in last, we will create the another tf file which is create.instance, which will look like this. Over here we are just providing the resource, instance type, and the AMI. Still you can see the AMI is hard coded. I'm not using the variable for the AMI. There is a reason why I'm not using the variable inside the AMI, because AMI is mapped with the reason. If you are using US East 2, you will have the different AMI. If you are using US East 1, you will have the different AMI. If you are using some other reason, then you will have the different AMI. So for this particular kind of configuration, we have the maps data type inside the Terraform. Right now, I'm not going to discuss about the map. Once we will go through the map, I will show you the same example with the help of the variable at a AMI. Right now, I'm not going to define the map and define the functionality of the map. So these are the files which we will create, and we will use the variables inside the configuration file. So in the next lecture, I will show you lab how we can use the variables. Thank you team. See you in the next lecture. Hello team, welcome back. Welcome to the Terraform training, and today we will see a lab on the variables inside the configuration file. We will see how we can defactor the configuration file and how we can execute the Terraform with the help of the variables. So let's go to the code editor first and let's create the configuration file as per the definition we have discussed in the earlier lecture. So here I am on my code editor and I will create a new folder with the section name, and this time the section name is Terraform variable detailed explanation. Over here first I will create a file and I will call it create instance.tf, and I will copy the resource section from the earlier create instance.tf and I will paste it over here. Here I will change something. I'm not going to provide the count over here, so I will remove the count. Then suppose I'm going to provide the AMI and I'm going to provide the instance type. Also I will remove the name and I will provide the static name demo instance. Let's save this. Now the second file I will create the provider.tf, and inside the provider.tf I will declare the provider with the help of the variables. So my provider.tf content will look like this. I am providing the provider AWS, then I'm defining the access key variable with the variable AWS access key, the secret with the variable AWS secret key, and the reason with the variable AWS reason. Now let's save this and I will create the third file which is called variables.tf. So I will call one more file and I will call it variables.tf, and I will define my variables inside this particular file. So I will define my variable like this. So inside this file I'm defining the variable AWS access key which is blank, AWS secret key which is again blank, and AWS reason. If we are not providing explicit, then we need to choose US East 2. Right, I will save this. Now we need to create the third file which we was talking about, and we need to add that file inside the git ignore. So let's commit these files and get the git pull on the Terraform machine. So the code is committed. I will go to the terminal and open the Terraform machine. We are on the Terraform machine. We will go to the directory Terraform, right? Put ls, and over here we have one directory start with Terraform basics. Let's execute git pull and execute ls again. Now you can see the second directory is also being created, Terraform variable detailed explanation. We will go to this directory Terraform variable detailed explanation, put ls, and we have my files over here, create instance.tf, provider.tf, and variable.tf. Let's clear out the console, put ls again. So right now we are defining the provider, we are defining the variables, and we are defining the create instance, but actually we are not defining the variable value. I'm not defining variable value anywhere. Over here inside the create instance we don't have any variable. Inside the provider I'm using the variable AWS access key, AWS secret key. Inside the variables I'm just defining the blank value over here. Only the AWS region have the default value US East 2. Rest AWS access key and secret key don't have any value. So now suppose you want to pass the variable at runtime, how you can pass the variables at a runtime. Now this is a new directory which we created, and if you remember I have told you that every time whenever you will create new directory you need to execute a command terraform in it to initialize the Terraform. This is the second time I'm repeating this command. From the coming section I will not initialize the Terraform every time. So execute terraform init, hit enter, it will initialize the Terraform. Right, initialization is done. Clear out the console. Now let's execute the command terraform plan. Although this will fail, but I want to execute it. And as you can see it is asking for the AWS access key. We are not defining the variable anywhere in any file, so it is asking for the access key. Let's provide some dummy key, hit enter. It is asking for the AWS secret key. Let's provide some dummy key, hit enter, and you can see it is basically starting the Terraform. Now we are getting 403 error. It has not asked for the reason because we are defining the default reason inside my variable. See, the default reason is US is 2. So it is taking the default reason US is 2, and we are getting the warning for the access key and the secret key. Let's clear out the console and execute the Terraform plan again. This time we will provide the correct access key. So this is my access key, and provide the correct value of the secret key. Hit enter, and you can see the Terraform plan is successful, right? It is saying 1 to add, 0 to change, and 0 to destroy. I'm not going to execute Terraform apply because I just want to show you that it is reading the variable or not, right? So this is the one way that it will ask for the variable which is not defined, and you can provide these variable at the prompt itself. Now let's see the another way. So we will execute the Terraform plan, and you can define -var. After this, you can define the variable name. So my first variable is AWS access key. I will define it equals to, put double quotes, and inside the double quote provide your access key, right? In the similar way, provide another var and provide the another variable. Another variable name is AWS secret key. Paste it here, provide double quotes and provide your secret key. Now hit enter, and you can see the Terraform plan is successful again. This is the another way. So we have seen two way. If we are not providing the variable inside the command, then Terraform will ask you to enter the variable values. And if we are providing the variable inside the command, that Terraform will not ask you to provide the values. Now let's see the another way which we have discussed in the earlier lecture as well. Let's create some file like vi terraform.tf variables, right? And inside this file we will define the variables. So first we will define the AWS access key, and we will define the variable of the access key. Then second, we need to define the AWS secret key, and we need to define the value of AWS secret. The reason is default I have declared. Let's save this file. Now after save your file, let's execute the Terraform plan again. Hit enter, and you can see it is reading the credentials from the terraform.tf var files. It is showing me the plan: 1 to add, 0 to change, and 0 to destroy. So we have seen all three ways how we can provide the variable value at runtime whenever the Terraform will ask, how we can provide the variables value inside the execution command itself, and how we can provide the variables inside the file as well. So clear out the console, put ls. We have the three files: create instance.tf, provider.tf, terraform.tf vars, and variables.tf. So that is the way how we can dynamically pass the value to the Terraform configuration file. Thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we are going to discuss about the composite variable in Terraform. We will discuss about the list and map variables in the Terraform. So first we will start with the list. So let's go to the code editor and let's see how we can use the list variable in Terraform. So here we are on our code editor file, and we will go to the variables.tf. Over here we was using the AWS secret key, AWS access key, and AWS reason. Now let's define one more variable, and I will define the variable name like security group. Here we will define the type of the variable by argument type equals to, and we will define the variable type is a list. After this we will define the default, and inside the default we will define the list of the variables. So we will open the square bracket first, and within the square bracket we will provide the security group list. So suppose I am providing SG-24076. This is the one security group. Now we are providing the another security group like SG-90809, and we are providing another security group like SG-456789, right? So these are the dummy security groups what I'm providing in my Terraform file. Now we have defined the security groups inside the variable, right? And we need to use that whenever we are going to create the instance. So inside the create instance.tf, I will declare one more variable, and the variable name will be security underscore groups. After this, we will define the syntax like dollar curly braces, where then the variable name. Variable name is security underscore group. I will copy this and provide it here. So using this way, we are providing the list of the security groups inside the security group of AWS instances. Let's save this and commit this code. Once commit, we will go to the machine where we are executing the Terraform. Here we are on the Terraform machine. We will go to the directory Terraform. Then we will go to the directory Terraform variables detail explanation. And after the git pull, let's verify the file create instance.tf, and we will have the recent code which we just added inside my file. Now over here, let's execute a command terraform plan, hit enter. Now after the git pull, let's put ls, and we have all the files variable tf create instance.tf. Let's get the file variable.tf, and you can see we have the security group variable over here, right, which is a list type and have the 3 values. Now let's execute a command terraform plan, and we will see if in the terraform plan we will get this list or not. So you can see here the plan is ready and we have one to add. If we will go to the security groups, and over here you can see inside the security groups we are getting the list. This is the list of the variables, so it means whenever I will create this instance, these security groups will be attached with that particular instance. So ideally these are the dummy security groups, so whenever I will apply the terraform, that instance creation will be failed. So I'm not going to apply that. I just want to explain how we can attach the list kind of variable with the terraform. Now we have seen how we can define the list kind of variables. Let's see how we can define the map kind of variable inside the terraform and how we can use the map kind of variables. So if you remember, you will go with the create instance.tf. You can see the AMI what I'm using over here, that is the hard coded value. And why we are using the hard coded AMI? Because in AWS machine image is dependent on the zone which we are using. And over here, if you go to the variables, we are using default US East 2. Now suppose we want to choose between the multiple regions, US East 2, US East 1, Ohio, US East 1, and the other regions. How you can solve that particular problem? So we need to provide some key value pair in our code where the key should be the AWS region and the value should be the AMI. Whenever we are providing a specific key, a specific AMI will be used. So let's see how we can do that thing. And that thing can be done with the help of the map variables. So inside the variable file, we will declare one more variable and we will call this variable name like MIs. Then we will define the type of the variable, and type we are defining the map. Then we will define the default, right? And inside the default, we will define the region and the AMI type. So we will go to the Google, and on the browser, we will choose the AWS AMI locator. We'll go with the Ubuntu ETC2 AMI locator or the finder, right? And over here, we are getting a list of the AMI. So suppose we are going to search for the US regions, and here are some US region and the corresponding AMI. So we have the multiple region and multiple AMI. Right now we have defined for the US East 2, right? And that is a Xenial type of AMI. Now suppose we are going to define the US East 1. So I will copy the US East 1 and I will provide the region over here. Then after the equal, we will put double quotes, and over here we will provide the AMI. So this is the AMI for the US East 1. In the similar way, we will choose US East 2 and we will provide the AMI for the US East 2. So for the US East 2, you can see this is the AMI for the US East 2. So I will copy this value and provide this AMI over here. In the similar way, we will choose some another region like US West 2. Provide it here, provide the AMI for the US West 2. In the similar way, we will choose some another region and AMI is this for the US West 1. So over here we are going with the 4 region: US East 1, US East 2, US West 2 and US West 1, right? If you want, you can define multiple regions and multiple AMI over here, right? But we are going with the 4 to explain this concept. I will save this file. Now I will go to the create instance.tf, and over here I will remove the hard coded value. Once I will remove the hard coded value, I will use a function lookup. Inside the double quote, I will provide where and then provide the variable of the AMIs, right? So AMI variable name is AMIS. I will provide the variable name over here, AMIS. Then provide the comma and provide the another variable like where dot, and this time I will provide the region, AWS region. So default region is US East 2, which is being defined over here. The corresponding AMI is defined over here. If you want to provide runtime, we can see how we can provide the runtime as well. So I will copy this variable and provide it over here. So what will happen once the code will reach at this particular location? Lookup function will search the value of the AWS region inside the variable AWS AMIs. Over here the value is US East 2, then it will go to the AMI variable and find out the US East 2. If US East 2 is present, then it will pick up this value. In the similar way, if the value of the AWS region is US West 2, then it will search for the US West 2 which is present over here and it will pick up this AMI. If we are providing some invalid value, then we will get the error as well. So let's save this and commit this code. Now on the Terraform machine, we will get the git pull. So I will clear out the console, and on the Terraform machine, we will execute the git pull. And you can see we got the latest code on the variable.tf and create instance.tf. Now let's execute a command terraform plan. Hit enter, and you can see we are getting the terraform plan 1 to add, right? If we will scroll a bit, and over here we can see we are getting this AMI. And let's see what is the reason we have defined against this AMI. So if I will find it, then we have defined the US East 2, and US East 2 is the default reason. Now let's clear out the console and execute the terraform plan again, but this time we are defining the AWS underscore region manually, and inside the region we will define US West 2, right? Hit enter. This will execute the terraform plan, and you can see plan is 1 to add. If we will scroll up, then this time the AMI value is got changed. If I will find out this AMI value against the region, control F, control V, you can see this is against the US West 2. So by this particular way, we can automate these kind of things where we have the key value pair dependencies. So we have seen how we can define the list and how we can define the map. We have seen almost the basic use of each kind of variable inside the Terraform configuration file and how we can make the Terraform configuration file independent from the environment. These files are environment agnostic. You can change the value and you can define the separate variable.tf for each environment, and that variable.tf will be used to provision the complete deployments in that environment, right? So if you have any doubt, any question, please let me know. Thank you team, see you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And in this section, we will learn about few building blocks of Terraform. We will see how we can start the deployment automation with the Terraform and how we can try the different approach with the Terraform. So in this series, first we will see how we can provision the software with the help of the Terraform. So till now we have seen that how we can spin up the machine on AWS, right? And that machine we are also executing with the base AMI, which is the default AMI in the AWS. But how that is helpful? Is that the only thing which your production service need? Is that the only thing which your application need? No. Machine launch is just 1% of the complete deployment automation, right? Whenever we launch the machine for some purpose, and that purpose is execution of a software. The execution of your software or the execution of the application also need support of other software as well. So today we will see how we can provision a software on AWS machines. So there are two ways to provision the software on the instance. The first is build custom AMI. It means till now we was using the AWS default AMI. So if we want, we can build the custom AMI. When I'm saying the building of the custom AMI, we can bundle the software and the files in the base image, and that can be done with a tool like Packer. Packer tool can help us to build the custom AMI. Right now, I'm not going to describe the Packer, but in coming lectures, I will show you how you can build the AMI with the help of the Packer. But here, let's understand what is the meaning of the custom AMI. Custom AMI means we will take the default AMI of AWS and then we will bundle few other software which we require to execute our application on that particular AMI, and then create another AMI which will install on the machine on AWS. We can take an example. Suppose you are executing some Java application. That Java application need the Java runtime environment, that also needs some other software like Tomcat, and that needs some other utilities like log rotation utilities, cron utilities. So what you will do, you will get the standard AMI of the AWS, then you will bundle the Tomcat Java runtime environment, and along with the Java runtime and Tomcat you can bundle the utilities as well. You can bundle the date utility, you can bundle the cron utility, and you can also bundle the log rotation utility. So once you will bundle all the utilities on your standard AMI, you will create another AMI from that particular bundle, and that will be the customized AMI. This can be done with the help of the Packer. This also can be done with the help of the Chef. Chef and Packer are the tool which will help you to create the custom images or custom AMI, right? They tool are not dependent on the cloud. With the help of the Packer and with the help of the Chef, you can also create the Google custom images, you can create the AWS AMI, and you can create the Microsoft Azure image as well. The second thing is boot the standard AMI and install software on the instance at runtime. This is the second way. So if we are not going to create the custom AMI, then what is the second way? Second way is we will boot or create the instance with the standard AMI, and then we will install the software at runtime before execution of my application. It means with the help of the standard AMI, we will create the machine, right? And on that machine, we will install the software at runtime. We will install the Tomcat, we will install the date util, the log rotation, and Java runtime environment, and then we will start the application. And then we will start our application on that machine. So team, just think about it from the production point of view. What is the preferred way? If you need to choose between two of these, the custom AMI or the custom image and the install at runtime, which you will choose? I will go with the first option. I will go with the custom AMI, because whenever we are executing the application on the production, that application is not just simply Tomcat. That application is not just simple the Nginx. A lot of thing depends on the machine type. A lot of thing execute whenever you are executing your application on the production. So that application needs some predefined and tested bundle. If every time you are getting the standard image, then the OS what you are getting, that OS is updated. Every time you are getting the updated operating system, and on the update and on updated operating system, you are installing the software at runtime. So we can understand this. Suppose your development was happening in the month of March. That particular feature freeze done in the May, right? So in May you have done the feature freeze, and your deployment automation code and your Terraform deployment automation code is freezed, right? Now that stuff which is freezed in the May is going on the production in July or in August. So whenever that code will execute on August, that will take the standard image or the AMI of the August, not of the May or June. So what is the difference over here? In these 2 months, if the basic operating system of the AWS is updated, then you will get the updated OS. And in that case, it may possible that some of the execution which you have built on the previous OS version, that may fail. So you may get the discrepancy in the actual environment and the tested environment. So by this way, the recommended way is create the custom AMI or create the custom image, because whenever we are creating the custom image, we know very well that what is the base image. When I'm creating the custom image, we have the fixed base image, right? And whenever we are updating the base image, so we are creating the another image. So we know very well that which version of the image need to be executed in the production. So these are the very small things, but these things are important. And this kind of knowledge also help you in the interview, because you can't learn these things if you're not experienced. If you're not doing these stuff, then you cannot explain the difference between both of these approach. At first sight, the second approach seems promising, but whenever we will go in the deep, the second approach is not a recommended approach, right? Although we need to execute something at runtime, but that is not the software installation, right? I never prefer software installation at the runtime. But if you want to do that, what we can do, we can create the script, and that script either the shell file or the Python file, and we will upload that script on the box. Then we will execute that script with the help of the utility remote exec. Remote exec is the provisioner in Terraform. With the help of the remote exec, you can execute the files. We have the other ways as well, like Chef, Puppet, and Ansible. These tools also help you to execute the script at runtime or execute the files at the runtime on the box. Chef is already integrated with the Terraform, so you don't need to worry about it. If you are executing the Chef statements, Terraform will execute these statements for you. User can run Puppet using the remote exec. If you want to execute the Puppet agent with the help of the Terraform, then you can use the remote exec to execute the Puppet agent with the help of the Terraform machine. For the Ansible don't have the inbuilt support in the Terraform. So first, with the help of the Terraform, you need to spin up the machine, then get the host IP or the machine IP, and then you need to execute the Ansible playbook on the host. If you want to upload the file on the instance, then this is the code which we can use. Over here, the highlighted code is basically uploading the install nginx.sh at etc location. So we need to use the provisioner file, right? We need to provide the source file, and inside the source file, you need to provide the complete path of the file, right? Then inside the destination, you again need to provide the complete path of the file, that at which destination you want to put that particular file on the machine on AWS. Then to execute the file, we need the remote exec, right? Remote exec will be used to execute the script. Either that can be the Python script or the shell script. These Python and the shell are the two preferred language in DevOps. So 99% people prefer Bash or Python to create the scripts for the software installation. Terraform provisioner, to execute the script, Terraform provisioner need to use the SSH on the Unix or the Linux box. But if we are using the Windows remote machine, then we need to use the WinRM with the help of the Terraform. So first, Terraform provisioner will create the connection with your machine. Once the connection will be successful, it will execute the defined script on your machine. User can use the connection to make the SSH connection on the host. Here is the sample code. So inside the provisioner file, you can define the connection. Then you need to define the user to create the connection, and the password of that particular user, which by which user you want to SSH on the instance. On AWS, user need to use the SSH private key and public key combination instead of the password. If you are using the Microsoft Azure or you are using the Google Cloud machines, then definitely you can use the SSH connections. But if you are using the AWS, then private public key combination is the preferred way. Here is the complete code which will help you to understand the way. So first we need to define the resource. You can define the resource name like AWS key pair. Then you need to define the key name. I'm defining, in my case, I'm defining level up hyphen key. Then we are defining key name, which is level up underscore key. And then we are defining the public key. Inside the second resource, we are defining the instances. And over here, we are defining the key name. You can see the key name is the combination of the resource, then key itself, then the key name, right? And in last, we are creating the connection. Inside the connection, we are defining the user, and we are defining the location of the private key. At runtime, whenever we execute the lab on this, there will be the small changes in this file, but this is the sample code how we can use the private public key combination to create the connection on the AWS machine. Again, once we'll create the connection, we need to use the remote exec to execute the script, and the format will be like this. The provisioner, inside the provisioner, we need to define the remote exec. Then inside the inline, we can define the comma separated commands. In the first command, we are providing the executable permission on my file, and in the second command, we are executing the file. So in the second way, first we are creating the instance, then we are installing the software, and in that case, what we need to do, we need to prepare a script, right? We need to upload that script. We need to create the connection on the box where we want to upload the script and execute the script, and then we need to execute the script, which will do all the things which is scripted inside your script. So thank you team. In the coming lecture, we will see a lab how we can install the software on AWS machine. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. In last lecture, we have discussed the ways of provision a software with the help of the Terraform. Today we will see how we can provision a software with the help of the Terraform on AWS. So for this, we have created few code files. So let's go to the code editor, and we will explain the code files which will be used to provision the software on AWS instances. So here I am on my Visual Studio Code, and I have created a directory Terraform concept building blocks, which is the name of this section. Over here I have created three files. Create instance file. You are already familiar with the create instance. We have created the provider.tf. You are already familiar with the provider.tf as well, because we have used these file in the last lecture. And third file is the variable.tf, right? Over here you can see I'm using few variables like AWS secret key, AWS reason, AWS security group, AMIs, and these are the few new variables which I have declared. So let's go through these files one by one. So over here you can see I have created one more file, install nginx.sh. This is the shell file which will install the nginx on my AWS machine. So we are going with the second approach where we will upload the file on the already running instance, where first we will boot the instance, then upload the file on that instance, and we will install the software with the help of the script file, right? So this is a shell file, and first we are checking until the instance will be ready. So until the instance will be in boot, this file will not execute. Once the instance boot will done, it will update the package manager of Ubuntu apt-get update. Then it will install the nginx, right? And after the nginx installation, it will start the nginx service. So this script will basically do three things. First, it will update the package manager, then it will install the nginx binary, and then it will start the nginx service. So this is the file which will be used to install and start the nginx on AWS instance. Now let's go to the create instance.tf, and on create instance.tf, first I am declaring a resource AWS key pair, and we have discussed about this resource. This resource is useful to access the AWS instance via connection or SSH connection. Here I am providing my key name level up underscore key. You can see I'm defining the key name variable and the value is level up underscore key. Then I'm defining the path of my public key. The path of my public key is defined inside the path to public key variable. This variable is defined inside the variable.tf path to public key variable, and the path is level up underscore key.pub. Because I will create the public key and private key in the same directory, so I'm just defining the file name. If you have the public key private key in another directory, right, you have the public key and private key inside the etc, then you need to define the path like etc slash level up dot pub or your key name dot pub. One more thing, over here I'm taking the key name level up underscore key. You can take any name, right? There's no limitations, you can take any name. Then inside the second resource, I'm defining the AWS instance. This is the instance name. Then I'm defining the key name. Inside the key name, first I'm taking the reference of the resource. Then I'm defining my key name. Then I'm defining my key name. And then I'm defining the name of my key. This is the tag which will be the name of the instance. Then you can see I'm defining the another provisioner over here. Inside the provisioner, I'm calling file, and file will be the install nginx.sh. This is the same file which is present over here, and I'm going to upload this file at a location temp. On the AWS machine, this install nginx.sh file will be uploaded at the temp location. Then for the execution of this file, I have the another provisioner remote exec. We have discussed about the remote exec as well, and over here I'm defining the commands which will be used to execute this particular file. Inside inline, I'm defining the first command chmod plus x temp install nginx.sh. It means provide the executable permission to this file. Then I'm doing sudo sed -i -e, replacing the cr characters with the null, right, in this file. This line is helpful whenever we are creating the shell file on the Notepad++. Sometimes whenever you will create the shell file on the Windows operating system, or you will download the shell file on the Windows operating system and then upload it, these files may have some unnecessary CRL or CRs characters, right? So we need to remove these characters if we are going to execute that shell file. Otherwise, bash will not execute that file, right? This statement is optional. If you are already using the Linux box or Unix box to create the shell files, then there's low possibility of the CR or CRL collectors inside that particular file. But there is no harm to include that particular line. After removal of the CR characters, what I'm doing, I'm executing the file temp install.sh. Over here, you can see every command I'm executing from the sudo. So you need to make sure whenever we are doing any kind of command execution with the help of the Terraform or with the help of the any scripts on the remote machines, it is a good practice to use the sudo so that we will not get the permission restriction errors. After the remote exec, what I'm doing, I'm defining the connections, and inside the connection, inside the host, you can see I'm using callsec functions which is accepting the private IP and the public IP. The type of the connection will be SSH. The user will be variable instance underscore username, and over here I need to define my private key. So I'm defining another variable file where path to private key. This is again declared over here, path to private key. So this is my private key and this is my public key. Public key path is defined inside the resource section, right over here, which will upload on the AWS, and private key will be present on the machine which is executing this particular script, so that we can create the connections, right? So this is the create instance.tf file. I have discussed about the install nginx. Provider.tf file don't have any new things, and inside the variable we have these two things: path to private key, which we discussed that this is the path of the private key on the local box. Path to public key, this is the public key which will be uploaded on the AWS instance. And instance username, right? The username which will make the SSH connection. In my case, this will be the Ubuntu user. Now let's go to the terminal and we will open the machine on which we are executing the Terraform. Now you can see we are on the machine Terraform, right? We will go to the directory Terraform. Inside the Terraform, we will put ls, and over here we have the two directories, start with Terraform basic and Terraform variables. Let's execute the git pull and put ls again. Now we are getting the new directory as well, which is Terraform concept building blocks. We will go to this directory Terraform concept building blocks, put ls over here, and we have all the files present: create instance.tf, install nginx.sh, provider.tf, and variables.tf. Now what we will do, let's check the Terraform plan. So I will execute a command Terraform plan, and this will fail. So it is asking to provide the secret key. I will provide my secret key, hit enter, and Terraform plan will be failed. And Terraform plan is filled with the Terraform init. So let's initialize the Terraform. Initialization is in progress. It's done. Clear out the console. Execute the Terraform plan again. Provide the secret key, hit enter, and it will fail again. It is failing for the path to public key. It means we need to generate the public key and the private key. To generate the public key and the private key on Ubuntu or Linux machines, you can use the SSH keygen utility. On the Windows machine, you can use the putty SSH generator to generate the private key and the public key. So I'm going to execute the SSH keygen. So I will execute SSH hyphen keygen hyphen F. Then we need to provide the key name. So let's go to the code editor, and here is the key name. And inside the create instance.tf, we have mentioned the key name. See, this is my key name. I will copy this and provide my key name. Hit enter. Now we are getting a message generating public private key. Hit enter. Hit enter again. The SSH key generation is done. Let's clear out the console. Put ls again, and you will get two more keys over here: level up underscore key and level up underscore key dot pub. Dot pub is the public key which will upload on the AWS instance, and this is the private key which will present on my local box, so that I can create the connection on the AWS instance with the combination of the public private key. Now let's execute the Terraform plan again. We need to provide the secret key. I'm not using the secret key inside the variable files and the environment variable, so that I need to provide it again and again. And you can see this time the Terraform plan is successful, right? Over here we are getting the complete public key as well. So this is the public key which is being printed on my terminal. See, public underscore key, key value pair id not known, and key name is the level up underscore key, right? AWS key pair level up underscore key will be created. This is the resource. This is the one resource where we are getting the key name and the public key. And this is the another resource, AWS instance, which is for the instance creation. We are getting the AMI, we are getting the machine type, right? And we are getting the destination check. We also have the name like custom instance, right? So that the output of the Terraform plan is plan add 2. The one is the AWS key pair resource and another is the instance itself. But before executing the Terraform apply, we need to modify the security group on the AWS. And why we need to modify the security group on the AWS? Because we are going to create the SSH connection on the AWS machine from my local machine or from the DigitalOcean machine. So the IP of my local machine or the IP of my DigitalOcean machine must be whitelisted on the security group of EC2 instances. So we will go to the AWS and we will sign in our account. Now once you will sign in, either you can go to the IAM or you can go to the EC2, right? We are opening the EC2, and over here inside the network and security you will get the security groups. We have one security group available, which is the default security group. We have already modified the security group in the earlier lecture as well. So let's again open it, and inside the inbound rule we need to add one more inbound rule. So I will click on edit inbound rules. You can see over here I already have a one rule, all traffic custom, and here is the IP. This is the IP of my DigitalOcean machine. If you are using your DigitalOcean machine, you have already configured it. If you are using your local machine, then you have already configured it, because we have discussed about it in the earlier lecture as well. Let's add one more rule, and over here I'm going with the all traffic from the my IP machine, right? So here is my IP 103.47.19243. This is the IP of my Mac machine which I'm using. I will save this rule. Now I will go back to the terminal and execute a command terraform apply. Hit enter, provide the security key, hit enter, and you can see it is asking for the confirmation. I will provide yes and hit enter. Now you can see we are getting a message creating AWS key pair. Creating computer after 1 second, ID is the level up key. Now it is creating my first instance. We are getting my first instance is still creating. So let's wait and verify the logs which we are getting on the terminal. Still creating the instance. Now you can see it has created the connection, the SSH connection with the user Ubuntu, right? And SSH agent is the false. Agent is connected, remote exec is creating the connection, and now you can see it is printing the logs where it is installing the Nginx on my machine. After the Nginx installation, it has started the Nginx, and we are getting apply complete resource to edit, zero change and zero destroyed. Let's verify the logs again. So over here we have seen that it has created the connection. After this, it has started updating the package managers, right? You can see here we are getting the percentage of the package manager. Package manager update is 100% done. Now it is reading the package of the list and fetching the Nginx software. Once Nginx software is 100% done, it is basically downloading the dependencies of the Nginx. Once the Nginx dependencies is also done, it is basically executing few softwares. See, it has configured the font config, it has configured the libjd, it has configured the libjpeg, right? And Nginx core. Supported and suggested package are also done, like libjd tools, fcwrap, nginx doc, and ssl secret. And new package also installed, and it is printing the complete list of the packages which is being installed as a part of the Nginx dependency. All installation is done, and once the complete installation will done, it will execute the Nginx service, and then it will show me the message that apply complete to resource edit, right? If you want to check, you can go to the AWS, refresh your AWS, or go to the running instance directly. You can see we have the running instance name custom underscore instance, which is the name which I provided with the ID 6944. If we will go back to the terminal, this is the ID 6944. If you remember, we have installed the Nginx on this machine, and we have already configured the security group with my current IP to accept the all kind of traffic. So if I will copy this IP, the IP of my AWS machine, put it here and hit enter, it will show me the Nginx page. See, why? Because Nginx is installed on this machine. So this is the way how we can provision the software on the machine with the help of the scripts. You can execute multiple script or n number of script as much as you want. There's no limitations. You can execute 1, 200, 200, 500 script on your machine, but the huge number of script will take a lot of time to provision your machine, right? Until Terraform will execute all the scripts, Terraform will not show you the success message of the provisioning of your instances. So this is the one way how we can provision the software on the AWS instances. When we will learn about the Packer, we will see how we can create the custom AMI as well, right? Now let's go back to the terminal and execute Terraform destroy. Terraform destroy is important because we are using the free account of AWS. Once the Terraform destroy will done, you are good. Provide the confirmation of the Terraform destroy, and over here you can see it is destroying the two resources. It means all the resources which is being created at the time of the Terraform apply, the same number of resources will be destroyed by the Terraform destroy. So team, this is the way how we can provision the software on the instance. Thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will discuss about the data source in Terraform. So after the variables, we will see what is the data source in Terraform and how we can use the data source to make the configuration file more dynamic in Terraform. So let's start with Terraform provides the data source for certain cloud providers like AWS. For different kind of data in AWS, you will get the data source in Terraform. Data source provide the dynamic information about the entities that are not managed by the current Terraform and configuration. It means if you need some dynamic information, but that dynamic information is not in used inside your existing configuration of the Terraform, then you can use the data source. AWS provides a lot of structured data which can be accessed by the AWS API. This is a very good thing about the AWS, that on AWS you will get a lot of APIs, right? Which will provide the structured data regarding the availability zones, regarding the AMIs, regarding the security group, regarding the IPs, or the things which can be publicly accessible. AWS have the API for all these things which can be easily accessible by the AWS console users or AWS customers. Terraform expose this information using the data source like AMIs and availability zone. So the information which is easily accessible over the AWS with the help of the APIs, Terraform expose the same information with the help of the data source. And with the help of the data source, you can dynamically consume the AMI, you can dynamically consume the availability zones, you can dynamically consume the IP ranges and all. When we are going to refer a resource inside the data source, that won't create the resource itself, and the plan will fail if the reference non-exist data or the infrastructure. It means the data source which we are creating, if that data source is not exist or we are using incorrect data source, then my Terraform plan will be failed. So dynamically Terraform will get the data, but Terraform will only get the valid data. If we are using some invalid data source, then definitely my Terraform plan will not execute. Data source also provide all IPs in use by AWS. It means all the IP ranges which AWS is using across the regions. With the help of the data source, we can get all the IPs with the CIDR range. This will help the IP based filter traffic. It means if you want to define the IP based filter traffic, that US people can only access the machine which is executing inside the US regions. The European people will only access the machine which are executing inside the Europe region. The Asian people can only access the machine which are executing inside the Asia somewhere, right? So you can do that IP based filter with the help of the data source if you want. So data source in Terraform will help you to configure that IP based filter as well. Traffic filter on AWS can be done by the security groups. If we are going to define that IP based filtering on the traffic in the AWS, then we need to define the IP filters inside the security group. In the security group, we have the two rules, one rule for the incoming traffic and another rule for the outgoing traffic. Incoming traffic means when someone is trying to access your AWS machine, and outgoing traffic means when your AWS machine is going to access some other machine. Incoming traffic can be managed by the inbound rules in security group, and outgoing traffic will be managed by the outbound rules inside the security group. Rules filter the traffic on the basis of the protocol, IP range, and the ports. So whenever we are going to define the IP based traffic filter in the inbound rule or the outbound rule, these rules will work on the protocol, what protocol is allowed, then the IP range, you need to define the IP range with the CIDR block, right? And then the port, on which port the traffic is accessible. So this is the basic definition of the data source. In coming labs, we will see how we can use the data source in Terraform. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will see how we can use the data source in Terraform. So let's go to the code editor and let's see how we can implement the configuration file with the help of the data source. Over here, I'm in my Visual Studio Code, and what I will do, inside the Terraform concept building block, I will create one more folder called demo data source. And what I will do, I will copy the files which are the part of the Terraform building concept inside the demo data source, and then I will modify the files as per my convenience. So I will copy the create instance first, then I will copy the provider.tf, and then I will copy the variable.tf, right? So now demo data source have the three files: create instance.tf, provider.tf, and the variables.tf. Let's close all these files from here and open these files one by one. First, I will open the variable.tf. From the variable.tf, you can see we have the access key, the secret key is blank, then we have the reason US is 2, and as per the reason, I have defined the AMI. See, I am defining the AMIs over here. Then we have defined the part to private key, public key, and the username. Let's remove all these three variables. We don't need these. Right now, let's go to the provider.tf. Inside the provider.tf, I'm providing the access key, secret key, and the reason, which we are reading from the variables. Then let's go to the create instance.tf. From the create instance.tf, I will remove this resource. This is not required now. We don't need the file provisioner as well, and we don't need the connection and the provisioner of the remote exec as well. Let's keep it simple. So over here, what do we have? We have the AMI, right? AMI is looking for the variables AMI on the basis of the AWS reason. We are getting the instance type, which is t2.micro, and then we are getting key name, key pair, level up key. Let's remove this as well because we are not using the private public key combination. This is the basic file we have, right? Now let's commit this file. Once you will commit the code, let's go to the machine where we are executing the Terraform. We are on the machine Ubuntu Terraform. Let's go to the directory Terraform. Inside the Terraform directory, we have another directory, Terraform concepts building blocks. Go to here, put ls, and these are the files which we have inside this directory. Let's execute git pull, put ls again, and we are getting the new directory. Let's go to this directory, demo data source, put ls. We have the create instance.tf, provider.tf, and the variable.tf. Let's execute Terraform init, clear out the console, and now we will execute the Terraform plan. It will ask for the security key. We will provide the security key, and here we are getting plan 1 to add. Now let's notice one thing. If we will scroll a bit, you can see over here we are getting availability zone, and inside the availability zone we are getting none after apply. It means we are not getting any availability zone where this machine should need to be deployed. So how we can get the availability zone at runtime? So let's go to the code file, and inside your create instance.tf, let's create the data source. So I will create like data. Inside the double quotes, I will provide AWS underscore availability underscore zones. Then again put the double quotes and provide available. And after this, I will make this data source as a blank. What this particular line will do? This particular line will fetch all the availability zones which are available inside the AWS. And to set the availability zone, we need to copy this availability zone, provide it over here, put equal sign, then provide the data dot provide this availability zones. What this availability zone will do, this will fetch all the Amazon AWS availability zone and put all these zones inside this variable. Now to choose the availability zone at runtime, we need to use this variable, and this variable will have the JSON data. So we need to choose like names and choose the availability zone which we want to choose, right? So generally in each region, Amazon have the four availability zone: A, B, C, and D. So let's go with the one. It means choose the availability zone which is present at index number 1. Index always start from 0 to 1. Let's save this file and commit this file. Go to the terminal and execute the git pull again. You can see one file changed, clear out the console. Let's get the file create instance.tf, and we are getting the latest code which we added, right? See. Now let's execute the Terraform plan. and over here we are getting the Terraform plan 1 to add. If we will scroll a bit, then you can see this time I'm getting the availability zone US East 2B, right? Earlier this was empty. So how we are getting US East 2? US East 2 we are getting from the variable, because we are sending the availability region inside the variable. See, US East 2. And how we are getting this B? This B I am getting from the dynamic data source which we have appended over here, right? If we will go to the terminal, clear out the console, and we will update this file, create instance.tf, and we will update this and keep the availability zone which is 0 or 2. So let's keep it. So let's keep it 2, right? Save this file and again execute the Terraform plan. Provide the secret key and hit enter button. Let's see what is the availability zone we are getting this time. And this time you can see we are getting US East 2C. So team, this is the way how we can use the data source to get the dynamic availability zone. If we will provide some invalid value, so let's update this and provide some invalid value like 7. Save it, again execute the Terraform plan, provide your secret key, hit enter, and you will get the error. It is saying that data AWS availability zone availability.name is list of a string with 3 elements. It means we have US East 2A, US East 2B, US East 2C, and US East 2D. We don't have this much of index inside the availability zone, so that we are getting the error. Let's update that file again and keep it file like 0, so that we will get the US East 2A. Save this and clear out the console. So this is the way how we can fetch the availability zone at runtime. But what if we want to fetch the AMI as well? How we can fetch the AMI at runtime? So to understand this, first let's go to the AWS. I'm on the AWS console. I will log in with my account, and let's suppose try to create the EC2 instance manually. So we will click on the EC2 instance and we will click on launch instance. The first thing which AWS will ask for the AMI. See, we need to provide the AMI over here. Let's try to provide the Linux AMI, right? I will search for the Linux. So here we are getting the different Linux AMI version. First we are getting the Amazon Linux 2 AMI, which is HVM. You can see over here the root device is EBS and virtualization type is HVM. Then we have the another Amazon Linux AMI. Then we have the Red Hat Enterprise Linux 8 AMI. Then we have the SUSE Linux AMI, and then we have the Ubuntu Server 20.4 AMI as well. You can see the virtualization type of all the AMI are HVM, right? But what is the different? Different is the provider. Over here, this AMI is basically being provided by the Amazon itself. This AMI is also being provided by the Amazon. This is being provided by the Red Hat. This is being provided by the SUSE Linux, and this is being provided by the Ubuntu. So whenever we are going to fetch the AMI runtime, we need to make sure that which provider AMI we need. So you will get the correct syntax inside the Amazon AWS documentation. Here we have an article called Finding a Linux AMI, and here is the Finding a Quick Start AMI documentation. I will attach this resource link inside this lecture, and you can see here it is finding the where the owner is Amazon and values is Amazon 2 AMI HVM 2.0. Same, it is finding for the Linux AMI. This is the Linux 2 AMI, and Linux AMI owner is the Amazon, then the AMI value name, which is again HVM, right? Here we are providing the name, which is state, and the values is available as well. Few other queries also being provided. If we will scroll down, you can see here is the Ubuntu server. And once we are going to search for the Ubuntu server, the owner is changed. Every time whenever you are going to find out the Ubuntu AMI, this is the hard code owner you need to provide. I'm talking about this image. And in the same way, if you're going to use the Red Hat Enterprise Linux AMI, then you need to hard code the owner ID like this. This time I'm talking about this AMI. So this is the way how you can find out the AMI at runtime. Now let's see how we can achieve the same thing in the Terraform. So To fetch the latest AMI, we will provide another data source like data. Inside the double quotes, we will choose AWS underscore AMI. Then after this variable, we need to provide some variable where this data store can store the value. Suppose we are going to use the Ubuntu AMI, so we will call it latest Ubuntu. Then we will provide the curly braces. Inside the curly braces, we need to provide the metadata regarding this data source. The first metadata we are providing is the most recent equals to true. It means it will fetch the most recent Ubuntu AMI. Then we need to provide the owner. We need to provide it in curly braces. Inside the double quotes, we need to provide the owner. So what is the owner for the Ubuntu? This is the owner for the Ubuntu AMI. So I will copy this and provide it here. Then over here you can see we have the filters, right? So in Terraform we need to assign the filter, and inside the first filter what we need to define, we need to define the name. So I will call name equals to double quotes name. Then after the name we have the values, so we will go with the similar. So we will go with the similar values equals to provide double quotes, and here it is going with the Ubuntu image HVM SSD Ubuntu Xenial AMD server hyphen. I will go with the same like this. But after this we will provide the asterisk for the regular expression, and I will put another filter. Inside this filter we need to provide the another filter which we have inside the image. So the another filter we have is the name, which is virtualization type, and inside the value we need to define the value which is HVM. Right now over here in the AMI you need to remove the syntax, and you can provide data dot provide the data name which is AWS AMI, then provide the actual variable where the AWS AMI are stored, and then provide the .id to get the ID of your AMI. Let's save this file and commit this file. After this, let's go to your Terraform machine and execute git pull. Now execute the git pull. Let's get the create instance.tf file, and we have all the changes we made. Right? Let's clear out the console and execute the Terraform plan. Terraform plan is in execution. We will provide the secret key, and we are getting an error that this should be a list, right? So we need to modify the create instance.tf a bit, and over here where we are fetching the values of the images, this should be the list. So I will provide it inside the square brackets. Save this and again execute the Terraform plan. Let's wait, and this time it is working, right? Let's see what is the AMI we are getting. So you can see we are getting the AMI ID this, right? Let's identify this AMI is present inside my variable file or not. And this is we are getting for the US East 2B. So if we will go to the variables, control F, and this is present. Now let's do one thing. Let's remove the default value for the US East 1 and US East 2. Right? I will delete these values and save this file. If we will check it over here on my box, you can see the values are being removed. Right? Let's clear out the console, and this time we will provide the custom reason to AWS Terraform plan. So we'll execute Terraform plan with the custom reason, and we are providing the reason like US East -1. Hit enter and let's see what we will get. We need to provide the security key, and you can see Terraform is in execution. We are getting plan 1 to add. Let's verify the AMI. We are getting the AMI 0F4C and some random ID over here. We are getting US East 1B is the reason, and T2.micro is the machine. If you will try to find out this AMI in your variable file, then this AMI is not present in your variable file. It means this is the AMI which we are getting at a runtime with the help of the data source. So we are getting two things at a runtime with the help of the data source. First is the AMI, and second is the availability zone. In the coming lecture, I will show you how we can get the IP filter with the help of the data source in AWS. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. In last lab, we have seen how we can use the data source for availability zones and the AMI. And today we will see if we want to filter out the traffic on the basis of the reason, then how we can create the security group on the basis of the reasons. So let's go to the code editor and first we will create the code in the local box. So here I'm on my code editor file and I'm working on the directory demo data source, which is the part of Terraform concept building directory. Over here in last lecture, we have developed three files, create instance.tf, in which we was using the data availability zones and AWS AMI as a data source. Then we have the provider.tf, which is the simplest file, and we have the variable.tf, which we have already discussed. Over here, we are getting the variable security groups. Let's remove this variable from here. And this is the content of the variable.tf. We have the access key, secret key, reason, security group, and the AMI's map. Now let's create one more file, and I will call it securitygroup.tf. Right, so here we have created the blank file called securitygroup.tf. In this Terraform file, in this Terraform configuration file, we will mention the code which will create the security group on the basis of the reason filter. So we will use the data, then we will provide AWS IP ranges, and we will save this value in some variable called, you can call it US East underscore IP range. Now you need to open and close the brackets. I will call it US underscore East so that it will be more clear. We are calling the variable name US underscore East IP range. Then we will define the reasons on which regions we want the IP filter, and we will define the reasons in the list. Inside the list, we need to define the reasons. So suppose I'm defining two reasons, and suppose we want to filter out the reasons US East 1 and US East 2. After this, we need to define the services on which services we want this IP filter. So we are defining the services, and this again needs to be defined inside the list, and over here we will define EC2. So we have defined data source for the AWS IP ranges, and inside the region we have provided the range US East 1 and US East 2. After this, we will provide the resource, and in the resource I will provide the AWS security group. Now you can provide your AWS security group name. So I'm providing custom US East SG, right? Or you can call it like this, SG hyphen custom US East. Let's open and close the brackets. We will define the name first, and we will define the name like, let's put the same name over here as well. Right, so we are accepting the security group name like this. After this, we need to define the inbound rules. For this, we will define ingress. It means the ingress traffic, and we will define from which port we want to accept the traffic. So suppose we are defining 443, we want to accept the traffic from port 443. In the same way, we will define two port, on which port on machine we want to send the traffic, and we want to send it on 443 again. Then we will define the protocol, which protocol we want to use, and suppose we want to use the TCP. And after this, we want to define the IP ranges. IP range can be defined with the CIDR block, and now we need to choose the data, right, which is this data. Then we need to choose the AWS IP ranges. This is the data source. After this, we need to choose the name of the data source. This is the name of the data source because all the values will be saved in this variable, US East IP range. Then we need to define the CIDR block range. CIDR block range is something which you have seen, first you define the IP, then after the slash you will define the IP CIDR range, right? If you're not aware with the IP CIDR range, you can Google around it. That is a very basic thing and you should know about it. After this, suppose we are want to provide some tags as well. So we will provide some tags. Inside the tags, first we will provide the creation date. So we'll provide like create date equals to data dot AWS IP range dot US East IP range dot create underscore date. Right, this will define the create date of this particular security group. Now we will define the sync token. So we will again define the data source like data AWS IP ranges, define the variable, then define the sync underscore token. So this is the variable file which I created, and over here you can see I'm creating one resource called AWS security group, right? The resource name will be like this, sg-custom underscore us underscore east. So this is the file which I have created for the security groups. Now let's do one thing. Let's commit this code. Once the code commit done, we will go to the machine where we are executing the Terraform. And over here, we will go to the directory Terraform. Then we will go to the Terraform concept building blocks. And then we will go to the demo data source. Over here, we will execute git pull. Right? Git pull is done. If you will put ls, you are getting the security group.tf as well. Let's execute the Terraform plan. And we are executing the Terraform plan with this variable US East 1, because in earlier lecture we have removed the mapping from the variables file. Hit enter. It will ask for the security key. We will provide the security key. Provide security key. Hit enter. And we are getting few errors. Oh, we are putting extra equal over here. We need to avoid this equals. So I will open the security groups. So these are the silly mistakes which you done, because whenever we don't have the proper documentation for the syntax, we do some mistakes. So I need to remove this ingress equals. I will save this and again execute the same command. Provide the secret and hit enter. And you can see it is processing. And right here you can see we are getting two resource to add, right? The plan is basically working to add. If you will see what two things are going to be add. So first it is going to add AWS instance, my first instance. This is the AMI. This will be the availability zone, which we are already using too. If we will scroll a bit downside, then over here we are getting the second resource. AWS security group name will be the SG-custom US East 1 will be created. This security group ARN is not defined. Description is managed by the Terraform. And over here inside the ingress, we are getting the CIDR block range. You can see these are the IP CIDR block range which is available inside the US East 1 and US East 2. See, we are getting a lot of IPs over here. This will accept the traffic from port 443. The protocol will be TCP and accept the traffic to port 443. The name of the security group will be this. We are adding the creation date and we are adding the sync token. Let's do one thing. Let's clear out the console and execute Terraform apply. Right? We will see we need to provide the security key again. Hit enter button and this will create one instance plus one security group. Let's wait. Provide the confirmation and it is creating the instance and security group. We have to wait until the instance and security group creation will be done, and it's done. See, the apply complete, one resource is being added. Now we will go to the AWS. On the AWS, you can go to the EC2 instances. So you can see one instance is running and two security groups are present. Let's open the instance running, and here is the custom instance running which I just added. If we will open this instance, if we will go to the security groups over here inside the network and security, let's click the security group. And now you can see we are getting two security group. One is this, which is the default security group, and this is the another security group which is being created by us. You can see the security group name is custom US East. This is the VPS, this is the VPC ID, and description we are getting managed by the Terraform. Over here you can see the inbound rules count is 50. Here we have just two permissions and outbound rules are 0. If we will open this security group, we are getting the owner, which is the ID. This is the security group name, the security group ID, inbound rule permission, description is managed by the VPC. And over here you can see inside the inbound rules we are getting HTTPS TCP on port 443. And over here we are getting the different IP ranges, right, with the CIDR block. If we will go to the tags, we are getting two tags. One is the sync token and another is the creation date. So this is the way how we can create the security groups dynamically with the help of the data source in the Terraform. Let's go to the Terraform again and execute Terraform destroy. Hit enter and it is destroying the resource which is being created. We need to provide the confirmation. Two resources need to be destroyed. Let's wait and resource destroy is done. If we will go to the AWS, we will go to the security groups. The custom security group is being deleted. If we will go to the EC2 dashboard, we are getting 0 running instances. So this is the way how we can dynamically use the AMI, how we can dynamically use the availability zones, and how we can dynamically create the IP filter on the basis of the IP available in each region. In my case, I have used US East 1. In your case, you can use US West 2 for your practice, right? And it always recommend to practice all these commands, all these configuration which we are doing over here. So because by this way you can learn fast, and whenever you will do some code by your own, you will try some new things as well, right? Which will provide you more confidence over the Terraform. So thank you team, see you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will see the output attributes in Terraform. So let's start with. So in the Terraform, we have an option to get the output. Terraform keeps the output of all the resources and its attribute. So whatever the resources we are creating in the Terraform, Terraform will keeps the output of that particular resource and the attribute associated with that particular resource. Output in the Terraform can be queried and retained. It means we can query on the output of the resource, and if you want, you can retain the output of the resource so that you can use that output further. The simplest example on this, you can retain the private IP address or the public IP address of the instances which you are going to spin. And whenever in the upcoming scripts, suppose you want to execute some Ansible playbook, so you need the IP of these machines. So you can retain the output of the public private IP, and if you want, you can use these IPs for the further work or in the further workflow. Output values are like to return values of the Terraform module and have the several use case. So we have the few use case of the output values. The first one could be that a child module can use output to expose a subset of its resource attribute to the parent module. It means if we are following the multiple modules, and definitely inside the configuration we have the parent child modules. So in the child module you can expose the output of some subset which can be used further by the parent module. So if we have the multi-level hierarchy in the configuration file and we want to expose or which is being calculated or which is being created by the child module, and we want that data in the parent module, so we can do that with the help of the output. Root module can use the output to print certain values in the CLI output after running the Terraform apply. It means suppose you want to print out some values of your resources, then you can print out these values on the console for the reporting purpose. These values will be printed on the Terraform CLI once you will execute the Terraform apply. When we are using remote state, we didn't discuss about the remote state, right? In the coming lecture we will discuss about the remote state as well, but right now you just need to understand the use. So suppose when we are using the remote state, which is a feature of the Terraform, root module output can be accessed by the other configuration by a Terraform remote state data source. It means we can use the Terraform remote data state data source, which can be useful to get the output of the configuration which is not the part of the current directory. Each output value exported by a module must be declared using the output block. So whenever you want to get the output of any value, you want to declare that value inside the output block, and syntax will be like this. You can define the output, then you need to define the variable name, that could be anything. Then you need to define the value expression, and after the value expression you need to define the attribute which you want. So over here it will get the AWS instance private IP inside the value of instance IP address. The value argument take expression those results to be returned to the user. This is a very important point, that outputs are only rendered when Terraform applies your plan, right? Running Terraform plan will not render the output. If we are just executing the Terraform plan, we are not going to apply that particular plan, then Terraform will not show you the output because none of the resource has been created. Terraform just created the blueprint of the resources, but none of the resource actually being created by the Terraform. So output will only be rendered whenever you will apply the plan, whenever you will execute the Terraform apply, right? Just putting the Terraform plan will not show the output. Output can also be used inside the script. You can also use the output in a script. So here is an example. Here we are creating a resource AWS instance. The name of the instance will be my first instance. We are getting the dynamic AMI, we are getting the instance type T2 micro, and availability zone is also dynamic. The name will be the custom instance. Then I have highlighted the command, right? Over here you can say we are using the provisioner local exec. Local exec and remote exec, two provisioners. We have discussed about the remote exec in the earlier lectures where we was executing the commands at the machine site which we have created with the help of the Terraform. Local exec is something which will help you to execute the command on the local machine. It means on the machine where you are executing the Terraform. And over here you need to define the command after the command expression, and command will be inside the double quotes. So over here we are executing echo AWS instance, then my instance name, then private IP, and we are putting that IP in a file called private_ips.txt. So team, this is the theory and the application of the output. In the coming lecture we will see how we can create the output and how we can use the output in the Terraform. Thank you team, see you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will see a lab on the output attributes. So first, let's go to the code editor and let's see how we can declare the output in the Terraform. So over here, we are on the code editor, and suppose we are going to work on the same data resource which we have created inside the demo data source. So over here, we have then file create instance.tf. Rest all of the files like provider.tf, security group.tf, variable.tf is already being discussed in the earlier lecture. We are just going to change the create instance.tf. And inside the create instance.tf, we have the resource AWS instance, my first instance. Over here inside this resource, we will define the attribute values. So first we will define the output, and suppose we are taking it public IP, then we are defining the value, and after the value we will define the public IP of the machine. So we will take the AWS instance. After the AWS instance, you need to take the instance name. After the instance name, you need to define the property, which is public IP. So what this will do, this will display the public IP of your machine on the console. Now suppose you want to execute some script as well and you want to capture the private IP in the file. So where you are creating the instance, over here we will define one more provisioner and we will name it my private IP, and we will define the provisioner local exec, right? Over here we will define the command, and inside the command we need to define the command which will capture the private IP. So we will define echo, then copy the same thing, and instead of the public IP we will define the private_IP, and we will write the private IP in a file called my_private_ips.txt. So this is the way how we can declare the values. So team, sometimes it may confuse you that how we are choosing this private IP, this public IP, that how do we know that this is the correct sentence, that we need to choose public_IP or we need to choose private_IP, or we need to go with this like AWS_AMI or like AWS availability zone. So how we can choose these parameters? So you can understand this, just go to the browser and type Terraform registry. You will get the registry.terraform.io. Let's click this. Just scroll a bit, and over here we are getting all cloud providers. We are getting AWS, Azure, Google Cloud Platform, Alibaba Cloud, Oracle Cloud Infrastructure, and the Kubernetes. Over here we are working with the AWS, so we will open the AWS, and here we are getting few versions as well, that 3.10, 3.9, 3.8. These are the versions which you will install on your machine whenever you will execute Terraform init on any directory. Just go to the documentation over here, and here you will get all the documentation. So suppose I want to search for the documentation EC2 instance, so I will type EC2, right? And over here you are getting the document like AWS AMI, AWS EC2 availability zone groups. There could be a lot of information which you can get, so that it will help you to create the Terraform files. Team, registry.terraform.io is the Bible of the Terraform. You will get all required information on this website, right? For an example, if you will go with the AWS AMI, then you can see we are getting the complete example, that how we can choose the AWS AMI resource, how we can choose the virtualization type, remote device name, EBS block device. There could be a lot of information and the complete description about that information. So whenever we are creating these files, don't confuse. You can also create your files, right? I believe you are learning very good stuff. But if you are ever surprised that how we are choosing that this particular term, or this particular term, you can go to the documentation and you can search around it. You will get each and everything inside the documentation. Now let's do one thing. Let's commit this code. After the commit, let's go to the Terraform machine. On the Terraform machine, we will go to the directory Terraform, Terraform concept building blocks, and demo data source. Over here, let's execute git pull to get the latest code which we done. Let's get the file create instance.tf, and we are getting the new code output and output command. Let's clear out the console and execute the Terraform plan. And we will execute the same command Terraform plan where AWS region US East 1, because we have removed the AMI from the variable.configuration file, and we are taking the AMI and availability zone dynamically. After the secret key, Terraform will start on the plan, and you can see after the plan we are getting something changed to the outputs. Public IP equals to known after apply. So as I mentioned that Terraform plan will not show you the, to get the output you need to execute the Terraform apply. So we will clear out the console and execute Terraform apply. After the Terraform apply, it will create one instance and one security group. Let's wait, provide the confirmation yes, it's still working, and you can see we are getting the complete Terraform state. Over here you can see it is saying apply complete, two resources added. Inside the output you are getting the public IP of your machine, which is 3.21.28.30. Let's copy this, go to the AWS, refresh your browser, and here we are getting one instance. Let's open it. Here we are getting the public IP of this instance. Let's identify this, and we are getting the highlighted, right? When we are searching the IP which is being printed on the console, that IP is being highlighted over here inside the public IP. If you remember, we have stored the private IP in a file. So let's open the instance, and the private IP address is 172.31.26.218. Now after clear out the console, let's put ls, and you can see the file myprivateips.txt is present. It means this file is being created by the Terraform. Let's see the output of this file, myprivateip.txt. And yes, we are getting the IP of my machine, right? This is the private IP of my machine, and on the Terraform CLI we was getting the public IP of the machine. So this is the way how we can display the output and how we can execute to store the output or retain the output of the Terraform resources. Once you're done, let's execute Terraform destroy. Provide confirmation, it will destroy resources. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will discuss about the Terraform remote state. We will discuss about the state of the Terraform, which Terraform used to maintain the state of the infrastructure, and we will see how we can make that state remotely available and what are the benefits to make the Terraform state remotely available. So let's start with. So generally we have seen that Terraform is able to find the resources it created and updated them accordingly. We have seen Terraform plan and Terraform apply commands. So if you remember, we are executing the Terraform plan and Terraform apply command in almost all the labs. And whenever we are going to execute the Terraform apply, Terraform is going to create the instances which is being defined inside my configuration. If the instance is already being created and you will create the Terraform apply again, nothing will happen. Terraform will display the message that instance are already present in the AWS. So how Terraform is basically finding that the resource is already created, and if we will update the configuration and again execute the Terraform apply, then how Terraform is basically identifying that what configuration need to be updated. That all thing is basically done with the help of the Terraform state file. So Terraform record the information about the infrastructure it create inside the Terraform state file. Terraform always create a file called terraform.tf state in the same directory where you are executing the Terraform plan and Terraform apply. That terraform.tf state file is a JSON file which will contain the complete infrastructure detail which is being pushed by the Terraform. Terraform also maintain the backup of the earlier state file in the named terraform tf-state.backup. So what is happening whenever you will execute a command terraform plan, Terraform will create a file called terraform.tf-state. And whenever you will create the Terraform apply, it will create the new file terraform.tf-state with the updated content and create the backup of the earlier terraform.tf state inside the terraform.tf state.backup file. With the help of these two files, Terraform will maintain the state of the infrastructure. As I told you that on command Terraform apply, Terraform backup is written and new state file is being created. So let me show you the status of the Terraform state and Terraform backup. So we will log into machine where we are executing the Terraform. So you can see here we are on the Terraform machine and we will go to the directory Terraform, Terraform concept building blocks, demo data source. This is the directory where we was working. If you will put ls, then over here you can see we have the file terraform.tf state and terraform.tf state backup. Let's do one thing. Let's remove these files. So I will call rm-rf terraform tf state and terraform tf state.backup. Put ls and you can see the terraform tf state and terraform tf state backup is being deleted. We are going to execute the same command because we have removed the AWS region from the variables. It will create the Terraform plan. Let's wait. You can see the Terraform plan is successfully done. Plan 2 to add, 0 to change and 0 to destroy. Over here you can see it is also going to show the state, right? That it is going to add two resources. 0 is change, it means nothing to upgrade and nothing to destroy. Now let's clear out the console and execute the Terraform apply. Hit enter. It will create the resources, right? Let's wait until the resources will be created. You can see the two resources are added and we are getting the output of the public IP. Let's clear out the console and put ls over here. Over here you can see the file is being again created. We are getting the file terraform tf state. If you want to show the content of this file, I will copy this file and execute cat terraform tf state. Then this is a JSON file which contains the complete data about your infrastructure. See, over here we are getting the complete CIDR block of the reasons which we are defining. We are getting the AWS security group, SG custom, and a lot of data is being present over here. So Terraform will maintain the state of the infrastructure with the help of the tf.state file. Now when we are creating some state file and we are maintaining the state of the infrastructure on the base of that particular file, then definitely this is going to be introduce some complications in the infrastructure. Let's discuss about the limitations and the complication the tf.state file is going to create inside the infrastructure and how we can overcome from these complications and the restrictions. So one of the management of the Terraform state file that if the remote state is changed, it means the state of the infrastructure is being changed and you are going to execute the Terraform apply again. Then Terraform will make the changes to meet the correct remote state. So you can understand this thing with the example. Let me switch to the console again. And over here, if I will clear out the console and I will execute the Terraform apply again, although I've executed the Terraform apply few minutes back, so you will get that all the resources are already present, nothing to change because all resources are present inside the AWS. See, we are getting apply complete, 0 added, 0 change and 0 destroyed. Over here we are getting the ID as well, that this is the AMI and this is the ID of the security group and this is the ID of your instance. Let's do one thing, let's go to the AWS console account and terminate the instance which is being created by the Terraform. So we are on AWS account, we will go to the EC2 instances and over here you can see we have one running instance. I will open it and I will forcefully terminate this instance. This is the same instance which is being created by the Terraform. What I will do, I will terminate the instance. I will select the instance and go to the instance state and click on terminate instance. If you will refresh this and you can see the instance state is basically shutting down. You can see the instance state is basically shutting down. Now what I will do, I will go to the console again and execute the Terraform apply again. Provide the secret key, hit enter. Let's wait. And over here you can see Terraform is going to add one resource. If you will put yes, hit enter. See, it is going to create the my first instance. If you will go to the AWS and refresh this, let's refresh again and you can see we are getting the new instances basically present. And this instance is basically being created by the Terraform because we are getting the ID 370F. 370F. So this is the way how Terraform basically maintain the state of your infrastructure. Although you have created or you have changed the remote state of your infrastructure, but as soon as you will apply that Terraform apply again, Terraform will maintain the state of your infrastructure. If you will put ls again then you can see the Terraform backup file is also being created. So whenever you will execute the Terraform apply again, it will create the Terraform backup file and capture the latest status of your infrastructure inside the terraform.tf state file. Let's do one thing. Let's execute terraform destroy because we are not going to execute anything on this environment. Provide security key. So we have seen how terraform will maintain the state of your infrastructure, and whenever you are going to change the state and going to execute the terraform apply again, that terraform will maintain the structure again. But we have the problem with this approach, right? What are the problem we will face with the state files? So first problem is the shared storage for the state file. So whenever multiple people or teams are working on the Terraform, right? Obviously, whenever you are working in the organization, you will have the multiple people or a complete team who is going to manage the infrastructure. You are not the sole person who is going to manage the infrastructure, but there could be the couple of people who are going to manage the infrastructure. And all of the people are executing the similar kind of commands on the same directory. Then we have the shared storage for the state file. It means the state file which is being created in that directory, that is created at some shared storage. You and your team can access that state file. So to be able to use the Terraform to update your infrastructure, each of your team member needs to access the same Terraform state file. That means you need to store those files in some shared location, right? That is the first problem, that whenever we are going with the team and my complete team need that state, then I need to share my state file with my team at some shared location. And whenever I'm going to make that state file at the shared location, anybody is free to change in that particular file what they want. Another problem with the file system is locking state file. It means as soon as the data is shared, you run into a new problem which is called locking. Without locking, if two members are running Terraform at the same time, you may run into the race condition as multiple Terraform process make concurrent update in the state file, which leads to conflict, data loss, or the state file corruption. Right? It may possible that one or two or many people are executing the similar kind of command at the same time, and if the state file are shared, then the Terraform will try to update all the commands output in the same state file. That may lead to the conflicts in the state file, that may lead to the data loss, or that may lead to the state file corruption. So we need to make sure that we will capture the lock on the state file so that at one time only single user will be able to apply the changes inside the state file. That is the another problem. And the third one is isolating state files. It means when making changes to infrastructure, it is best practice to isolate different environments. What does it mean? It means it may possible that you are going to execute the same Terraform infrastructure across the multiple project. That could be the multiple production project, that could be the one production and one pre-production qualification, and that could be the engineering or the performance environments. So we need to make sure that the file of the each environment should be isolated. It should not be happen that the file of the pre-production environment will shared on the production environment and execute on the production environment, because that will change the configuration of your production environment. So we have the three issues with the file system. The first one is the shared file location, second one is the locking with the file, and third one is the isolating the state file systems. Most common technique to allow the multiple team members to access the common set of files to put into the version control system. So the first problem we have with the shared location, and that can be easily solved if we have the version control system, right? What we can do, we can push the files on the version control system, and everybody can capture that file. They will get the git pull, and they will make the changes, and they will get the git push. So that a single state of the Terraform file will be maintained in the version control system. But this is not a good idea. Why this is not a good idea? Because this will lead to the manual error. What kind of manual error it will lead? It's too easy to forget to git pull and the latest changes from the version control before running the Terraform, or push your latest changes to the version control after running the Terraform. That is the basic problem with the engineers. They may forget to get the git pull before the git push. And what will happen if you are not getting the latest file state and you are going to execute the Terraform apply? It means you are going to execute the Terraform apply with the stale files. stale file don't have the updated environment details, and you will change the already deployed environment as per the stale files. Also, whenever you will push the changes to the version control system, you will upload the stale file to the version control system. So that is not a good idea to keep the state files in the version control system at some shared location. The second one is the locking. Most version control systems do not provide any form of locking that would prevent two team members to running Terraform apply on the same state file at the same time. Definitely, this is not the feature of the version control system. The locking is not the feature of the version control system, so we cannot expect the locking from the version control system on the Terraform files. And third one is the secrets. So all data in the Terraform state file is stored in the plain text. This is a problem because certain Terraform resources need to be stored some sensitive data. Whenever you are going to create some database resources, some database servers, you need to mention the database name, database password inside the Terraform, and that thing will be inside the plain text. And whenever you are going to mention the password and the server's name inside the plain text, and you are going to push that code inside the public repository or the private repository, then that is also harmful because you are going to set the password of your environment to the public. So these are the challenges with the version control system if we are going to maintain the state file on the version control system. So what is the solution? So instead of using the version control system, the best way to manage the shared location for the state file to use Terraform built-in support for the remote backends. Remote backend is the functionality which will solve all these challenges which we have discussed with the state files. The Terraform backend determine how Terraform loads and store the state. So you don't need to worry about the management of the state files inside the Terraform. Terraform have the built-in features which is called remote backends or the backends. Remote backend solves all our problem we listed earlier, right? That will solve the manual error because once you configure a remote backend, Terraform will automatically load the state file from the backend every time you run the Terraform plan or Terraform apply. It will automatically store the state file in that backend after each apply so that there is no chance of the manual error, right? We don't need to get the latest state of the state file, then change it and then push it. No, every time whenever if the remote backend is configured with your Terraform and you are going to execute the Terraform apply, Terraform plan, every time you will execute the Terraform apply, the latest state of the file will be uploaded inside the remote backend, and that will be synced with all the developers who are working on that particular project. The second one is the locking. Most of the remote backends natively support the locking. It means that Terraform have the multiple approach for the remote backend and most of them supports the locking. To run the Terraform apply, Terraform will automatically acquire a lock, and if someone else is already running the Terraform apply, they will already have the lock and you will have to wait. It means if you are using the remote backend, whenever multiple users are executing the Terraform apply, Terraform will lock the state file for the first user. Once the execution of the first user will complete, Terraform will release the lock and the execution of the second user will take place. So locking system is also being managed by the Terraform itself. You don't need to worry about it. And third one is the secret. So most of the remote backend natively support the encryption in the transit and encryption on the disk for the same state file. So whenever you are using the inbuilt remote backend and you are going to mention the secret inside your file, then remote backend support the encryption in the network transit. Whenever your data is flowing from your local machine to the AWS or Google Cloud remote state, then the data will be encrypted between the network, right? And data will be encrypted on your on disk as well. So here is some sample that how we can store the state files inside the S3 bucket. S3 bucket is one of the remote state management approach. And if you want to use the S3 bucket remote state, then you can use the below syntax. You need to define the Terraform. You need to define the backend that we are going to use the S3. You need to define your bucket name and the key and the reason. In which reason the bucket will be created. Here the key will solve the isolation problem. Inside the key you can define the environment specific key, right? So although we are going to create the Terraform state file with the same configuration, but with the help of the key we can identify that this configuration is for the production, this configuration is for the pre-production qualification environment, and the another state file is for the development, another state file for the some regression environment. While using AWS S3 backend, it's recommended to use the AWS configuration instead of the AWS CRUD in the variables. That is the important point. Whenever you are using the remote state inside the AWS S3, it is always recommended to use the AWS configuration, because the backend service in Terraform will not use the variables. And if we are going to define the secret and the API key inside the variables, then Terraform will not be able to create the remote backend on the AWS S3. So thank you team. In the next lecture, we will see the lab on the remote state of the Terraform. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And today we will see a lab on the remote state. In the earlier lecture, we have discussed about the state that Terraform maintain to manage the infrastructure. And today we will see how we can make the remote state or the remote backend in the Terraform with the help of the S3 bucket. So first, let's go to the AWS account and create a S3 bucket in your AWS account. So here we are on the AWS, and here inside the services, we will search for the S3. So we are getting S3 scalable storage in cloud. We will click it. And if you don't have any S3 bucket, which is already configured, you need to create a new S3 bucket with this button, create bucket. I will click the create bucket. It will ask few questions. You need to provide the bucket name, and please make sure the bucket name should be globally unique. So we are going to provide tf-state, then some random ID 98FTY. We are going to create the region in US East 2. We are not going to copy the bucket content from any existing bucket. Click on the next. Inside the configuration option, we will get the first option of the versioning. We will keep the versioning because somehow if accidentally we will delete the tf-state file, then we can retrieve the earlier version tf-state file from the S3 bucket. We don't need the server access logging. If you want tags, you can add the tags. You can add multiple tags over here. And if you want the encryption, you can go with the automatic encrypt object when stored in S3. We will go with the default encryption. Then we will click on the next. And here it is saying block all public access. And we will click on the next. Here we are getting the review and click on the create bucket. So you can see a new bucket is being created, tf state 98FTY. Now we will go to the code editor, and inside the demo data store, I will create a new Terraform file called backend.tf. And over here, I will provide the code or the configuration which will help Terraform to maintain the remote state of the Terraform. So we will call Terraform. Inside the Terraform, we will call backend and define the backend name S3 bucket. Define the bucket name which you can get from the browser, S3 bucket. So this is the bucket name. I will copy the bucket name, provide on my code editor. After this, you need to provide the key to separate out the project. So suppose I'm providing the key like development slash terraform state. Now this is optional. If you want, you can provide, and if you want, you can skip. You can provide the reason in which region your bucket exists. So I've created the bucket in US East. So we'll search for the region of the US East, and this is US East 2. And we have created the bucket in US East Ohio. So you need to provide the region US East -2. So provide US East -2. Let's save your file and commit your code. Once the commit will done, we will go to the Terraform machine. We are on the Terraform machine. We will go to the directory cd terraform, terraform building concept, and demo data source. Over here, let's execute git pull, put ls, and you can see we are getting the file backend.tf, cat backend.tf, and we are getting the data over here, right? This is the S3 bucket name which we have created. This is the key, and this is the reason where we have created the S3 bucket. Let's clear out the console. And as per the last lecture, first we need to execute the AWS configure to configure the secret and the key. So I will execute AWS configure. Hit enter. And to execute the AWS configure, first we need to install the AWS CLI on the machine. And to install the AWS CLI, you need to execute sudo apt-get update. Once the update will done, you need to execute sudo apt-get install AWS CLI. Hit enter. Provide your confirmation, hit enter button. It will install the AWS CLI on your Ubuntu machine, right? So we are downloading the AWS CLI from the package manager. If you want, you can go to the AWS official documentation, download the zip, unzip the AWS CLI and execute the shell file to install the AWS CLI. But this is the easiest way to download the AWS CLI on the Ubuntu machine or the Linux box. Let's wait until the installation will be done. It will download the AWS CLI plus all the dependent libraries which is required to execute the AWS CLI. So sometime it will take time. Once the installation will be done, you need to clear out the console and execute a command AWS configure. Hit enter. It will ask for the access key. You need to provide your access key. Then it will ask for the secret key. You need to provide your own secret key. It is asking for the default region. If you want, you can provide. I'm providing US East 2. It is asking for the output format. Hit enter button and it's done. Let's clear out the console and now let's execute the Terraform init, right? And we are getting the unsupported backend S3 bucket. So I believe this should be only S3. So if I will edit the file, so I will edit the file and commit it again. Once the commit will done, I will get the file on my box again. So I will execute git pull, right? And I will execute the Terraform init again. It's done. Clear out the console and execute the Terraform plan. Let's execute the complete command. Hit enter. Provide your secret. It's done. You can see it is going to add two resources. Clear out the console and execute the Terraform apply. Provide the secret key. Hit enter. Provide your confirmation and hit enter key. And on the AWS, we will go to the bucket. So over here inside the bucket, you can see a new directory is being created called development. And if we will go to the development, we are getting the file Terraform state. You can see the file is encrypted. If you are going to download the file, you can download this file from this button. And here is the JSON file. Let me allow to open this file. And you can see this is the Terraform file which is being created. I will close this. And here we are getting the e tag of this file. Let's copy this e tag. Go to the AWS console management, go to the EC2 instances, go to the running instances, and let's do one thing. Let's terminate this instance. So I will select this and I will terminate this, right? As soon as the termination is initialized, you need to go back to the console and execute the Terraform apply again. You can see it is going to add the destroyed resources. We will provide the confirmation, hit enter, and it will create the new instance soon. We are getting a message that my first instance is basically in creation. Let's wait until the instance will be created and it's done. Now we will go back to the AWS again, go back to the S3 management console and refresh this web page. You can see this e tag is being changed. Earlier this was E5, now we are getting 4A3, right? And over here we are getting the latest version of this file. If I will go to the versions, you can see we have the earlier version as well. Let's go to this version. So this was the e tag earlier, 75E5. And this is the new Terraform state file which is being created once I executed the Terraform apply second time. So this is the way how we can maintain the remote state of the Terraform. And if multiple users are going to execute the Terraform apply and Terraform plan in this remote state, then we will get the feature of lock as well, right? So I hope right now it is pretty much clear that what is the remote state and how important to maintain the remote state of your Terraform project. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And this is a new section where we will discuss about the AWS with Terraform. So in this section, not only Terraform, we will discuss about the AWS, the concepts of the AWS and different services of the AWS. Then we will see how we can deploy these services with the help of the Terraform. So in this row, first we are going to discuss about the VPC in AWS. VPC is a short form of the
virtual private cloud. So first we will see the VPC in AWS, and then we will see how we can deploy the VPC in AWS with the help of the Terraform. So let's start with. So first let's try to understand what is the VPC service. Amazon Virtual Private Cloud, or in short we can call it VPC, enables user to launch AWS resources into a virtual network that you have defined. So in the earlier lecture, we have seen that AWS EC2 instances was using the default network. But in AWS, we have the liberty, we can create our own network, which is called Virtual Private Cloud Network. Amazon VPC is the networking layer for the Amazon EC2 instances. The network which we are going to define inside the VPC, we can use that network inside the EC2 instances, and the specified network which will be associated with the EC2 instances, that particular EC2 instance will use only that network. Network layer in AWS project create a separate isolation between the communication of the different instances, right? We will discuss about it shortly. For fresh account, Amazon have the default VPC network. Actually, if you don't have any VPC network in the AWS, not even the default, then you cannot create the EC2 instances in the AWS. To create the EC2 instances, network is mandatory thing. So either you should use the default network or you can use your own VPC network to create the instances in AWS. Best practice to always create your own VPC with your own setting and the configuration. So although the default VPC network is there, but that have the default configuration which is being defined by the AWS. Whenever you are working in your organization, you are setting up the machine or the network for the production, then it is a best practice to configure your own VPC with your own setting and with your own configuration, because you know very well that what is your requirement, and as per your requirement you can create the network which will be used by your instances in the production machines. Let's discuss about the few key points and the terminology of the VPC in AWS. So first is the virtual private cloud VPC. A virtual network or the VPC network is dedicated to your AWS account. You can create more than one VPC in your AWS account. Then second thing, we have the subnet. Subnet is the component of the VPC. Inside the subnet you can define the range of the IP addresses which will be valid inside your VPC. So whenever we are defining the VPC, we will define the different subnet in that particular VPC. In the VPC, we will define the IP ranges, that which IP range will be associated with the instance which are going to spin in that particular VPC. Then we have the route table. Route table is something which will set up the rules for your network, right? And these rules are called the routes, that are used to determine that where network traffic is redirected. So within the route tables, you will define that which machine can access your network, right? And the machine which are using your network can access which machine outside your network. So route table is simple terms. If you are from the networking background, you can understand the route table very easily. Route table is something where we will define the different routes of the network which network can use to communicate with the other network or within the network. Then we have the another component called internet gateway. Internet gateway is mandatory if you want to expose your machine to the internet. So a gateway that you attach to your VPC to enable communication between the resources in your VPC to the internet. So whenever you want to open the connection to internet from your virtual private cloud network, you always need the internet gateway associated with your VPC. And the next one is the VPC endpoint. VPC endpoint enable the private connection your VPC to supported AWS services, right? VPC endpoint service powered by the private link without requiring the internet gateway, net device, VPN connections, and the AWS direct connection. So whenever you want to set up some private connections, right, you can use the VPC endpoint within the AWS. Now let's understand what a user can do with the VPC. What the use of the VPC for the user. So launch instances in a subnet of your choosing. You can choose your own subnet addressing. So whenever you are going to spin the EC2 instances in your AWS project, you have the liberty to choose the network, right? And in that network, you can choose the subnet which will define the IP address of your machine. You can also assign custom IP address ranges in the each subnet. So whenever we are defining the subnet in the VPC, we can define the customized IP range inside the subnet, which will help us to make the system more secure. Because whenever we are defining the different IP ranges inside the subnet, and we want to make sure that a particular subnet machine can access the internet and the another particular subnet machine cannot access the internet, so we can spin up the machine in that way, right? Which machines require the internet access, they will be spinned up in the subnet which have the access to the internet. So we can do a lot of things if we are defining the subnet inside the VPC, and these things will be mostly related to the communication and the security. User can configure the route tables between the subnet. So if we are defining the multiple subnet to enable the communication across the subnet, we can define the route table for the subnets. As we already discussed, that user can create the internet gateway and attach it to the VPC. VPC provide much better security control over your AWS resources. So definitely, if we have the customized and we have on-defined network, so we can manage that network more better, which is defined by the AWS. Because whenever we are defining our own network, we know that who can access my network and to whom my network can access. User can assign the security group to the individual instances. So security group is the another thing which will define that what traffic the instance can accept and to whom the instance can access. That security group can be defined at the individual instance level. User also have the subnet network access control list, which is called ACLs. ACLs is something which will define the control at the subnet level inside of the VPC level, which will make the VPC more easy to use. For the small or the medium setup, one VPC will be enough. So if you are working in a small organization or in a medium size organization where we have the customers or the users which is between 10 to 5000 or something like that, the one VPC or the medium VPC will be very enough for our organization, right? The instance which is launched in one VPC can never communicate to the instance lodged in the another VPC via private network. So suppose if we have the two VPC, VPC A and VPC B, some instance called C is launched in the VPC A and some instance called D is launched in the VPC B. So we have the two instance and both instance are using the different VPC. Now suppose instance C want to communicate to the instance D, right? Then that communication cannot be possible with the help of the private IP. With the help of the private IP, instance can only communicate within the VPC, right? Within the virtual private cloud network, you can only communicate with the private IP, but if you want to communicate outside the virtual private network, you need to use the public IP. Public IP is a must setup for the inter VPC communication. We cannot communicate across the VPC using the private IP only. Two VPC can be linked by a VPC peering, right? So we can link two VPC via VPC peering. In the modern organization, VPC peering is a very common thing. So if you want to pair up multiple VPC, you can use the VPC peering. Let's discuss about the VPC peering a bit. VPC peering is a network connection that allow you to connect one VPC with another VPC through a direct network route using the private IP addresses. So whenever we are going to define the VPC peering, basically we are creating the bridge between two VPC, right? Which will enable the VPC machines to communicate over the private IP instead of the public IP. As I told you that machines which are present in two different VPC can only be communicate over the public IP. But if we are defining the VPC peering, then both of the machines, then the machine of the both VPC can communicate to each other using the private IP only. When we are defining the VPC peering, then the instance of the both network will behave like they are on the same network. User can pair VPC with the other AWS account as well, right? On other VPC in the same account as well. So if you want to pair up the VPC, right, you have the two VPC in the same account, you can pair up these VPCs. If you have the two VPC in two other AWS account, you can also pair these VPCs. There is no such limitation. User can pair between regions. Suppose you have one VPC in one region and other VPC in another region, then you can pair up the VPCs between the different regions, right? So suppose we have the machines inside the different region. I'm I have the one VPC in US East 1 and have the another VPC in US East 2. So in both of the regions we can set up the VPC and we can pair up then VPC so that the machine which are present in the US East 1 can communicate to the machine on the US East 2 on the private IP. One VPC can connect via one or more VPCs. So we can pair up one VPC to one VPC or one VPC to n number of VPCs. So team, this is a bit information about the VPC in AWS. Thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And today we are going to continue the last lecture AWS VPC introduction. Today we will see some more things about the AWS virtual private cloud network. So let's start with. So first let's discuss about the subnet in VPC. What is the subnet in VPC and what is the use of the subnet in virtual private cloud network? So virtual private cloud network is a virtual network dedicated to your AWS account. It is logically isolated from the other virtual network in the AWS cloud. So whenever you are going to define your virtual private cloud network, that virtual private cloud network will be available exclusively for your own account, right? On the AWS, there could be the million of the virtual private cloud network. But the virtual private cloud network which is associated with your account, that is your own network. No other VPC can interfere with your own VPC. The VPC which you are defining in your account, that is your VPC network, and all the machines which are using that particular VPC, you have full control of the network on these machines. When you create the VPC, you must specify the range of IPv6 addresses. Whenever we are going to create the virtual private network, we must need to specify the range of the IPv4 addresses for the VPC in the form of caseless inter-domain routing, which is called CIDR block. So whenever we are going to define the VPC, we need to define the IP range for that particular VPC, that which range IP can be associated with the machine which are going to spin up in that VPC, right? And that IP range must have the CIDR block range. So here is an example. Suppose we have an IP range like 10.0.0.0/16 in the primary CIDR block of your VPC. Here 16 is the CIDR block and 10.0.0.0 is the IP range. Whenever you are going to define that particular range, then the IP addresses which will be associated to the instance which are going to use that VPC will be in range of 10.0.0.0 to 10.0.255.255. VPC spans all the availability zone in the region. After creating the VPC, you can add one or more subnet in each availability zone. So whenever we are going to define the VPC for a particular region, then all the availability zone in that particular region, that could be the A, B, C, D or ABC, right? Generally, the regions have four or three availability zones. So all the regions which are the part of that availability zone in which we are going to define the VPC, they will be by default included in that VPC. If we are going to define a particular IP range for each subnet, we can define that IP range as well. If a subnet traffic is routed to an internet gateway, the subnet is not as a public subnet. So whenever we are going to allow the traffic from the internal instance to the internet, then that subnet will be called as the public subnet. If the subnet does not have a route to the internet gateway, then the subnet is called the private subnet. VPC and the subnet sizing for the IPv4. So this is the defined subnet sizing for the VPC in AWS. You can define the 10.0.0.0 with 8 CIDR block, right? That will range the IP from 10.0.0.0 to 10.255.255.255. In that case, if we are going to define 10.0.0 inside the subnet, then user must define the CIDR block /16 or smaller. The another range for the IPs is 170.16.0 to 172.31.255.255, which is with the IP range of 172.172.16.0.0 with the 12 CIDR block. Your VPC must be /16 or smaller for the example like 172.31.0.0. And the third and the last size range block for the VPC is 192.168.0.0 with the CIDR block 60. Whenever we are going to define the CIDR block in the VPC, the following rule must be applied on the IP ranges to allow block size between 28 net mask and 16 net mask, right? So it means we cannot define the CIDR block more than 28 and less than 16 in the IP range. CIDR block must not overlap with any existing CIDR block that associated with the VPC. So suppose earlier you have defined a CIDR block like 10.0.0.24. Later you cannot define the 10.0.0.16, right? That overlapping is not possible, right? So we always need to avoid the overlapping inside the IP ranges whenever we are going to define a new IP range inside the existing VPC. User cannot increase or decrease the size of existing CIDR block. So once the CIDR block is defined, the IP range is defined inside the VPC, that existing CIDR block cannot be changed. You can add new CIDR block with the new IP range, but the existing one cannot be changed. That either cannot be decreased or increased. Let's discuss a bit about the security group as well. What is the security group in AWS? So security group act as an virtual firewall to your instance to control the inbound and outbound traffic. Security group is an entity in which we will define that what is the inbound traffic and what is the outbound traffic. Inbound traffic means which IPs can access my machine, and outbound traffic means to which IP my machine can access. Security group can be individually associated with the instance group. You can define 1 to n number of security group within the defined quota in your AWS account. We can associate up to 5 security group to a single instance in the AWS. Not more than 5 security group can be assigned to a single instance in the AWS. And if you have a requirement to assign or associate more than 5 security group to a particular instance, then it means there is some problem in your approach, right? Because 5 security group is more than enough for any instance. Generally, people prefer either one or two only. I really don't remember whenever I required to associate more than two security group with a single instance. Although in 90 to 95% cases, a single security group will be much for an instance in the AWS. Security groups are the instance level, not the subnet level. We are discussing this thing since starting that the security group can be associated at the instance, not at the network level, right? Let's discuss few basics of the security group. User can specify the allow rule but not the deny rule. Inside the security group, you can only define the allow rule. What traffic is allowed for the outgoing and the incoming. You cannot define the deny rule in the security group. User can specify the separate rules for the inbound and outbound traffic, right? There is no limitations. You can define the separate rules for the inbound and the outbound traffic inside your security group. Security group rules enable you to filter the traffic based on the protocol and the port number. So whenever we are going to define the security group, then including the IP range, we also need to define that on which protocol and which port I am going to allow the traffic on my instance, and on which IP, which port and which protocol I am going to allow the traffic from my instance, right? So we need to define all three things whenever we are going to create the security group in AWS. By default, security group don't have any inbound rule. We need to associate the inbound rule with the security group. The default security group don't have any inbound rule, so that if you remember in the AWS, we was opening the traffic from the Terraform machines to the AWS machines using the security group inbound rules. By default, a security group include an outbound rule that allow all outbound traffic. It means access the internet by default to all the machines. The AWS instance by default have the access to all the machines. There are quota on the number of security group that you can create per virtual private cloud. The number of rules that you can add to each security group and the number of security group that you can associate with the single interface. So as I told you that inside the public cloud, you have the quota for each and everything. You have the quota for the route tables, you have the quota for the security groups, you will have the quota for the load balancers, you will have the quota for the instance group, you will have the quota for the EC2 instances, for the buckets. Each and every resource which is available in your AWS account, the quota must be associated with that particular resource so that nobody can misuse the resources in the AWS. So that's all about the VPC and the security group. In the coming lecture, we will see a short demo on the VPC and the security group. Thank you, team. See you in the next lecture.